Okay, guys, welcome back. Now we're going to talk about the views. What does that mean, a view? Sometimes, in many cases, not desirable, for example, for all the users going to have or access the entire data. For example, assume that we have the instructor relation, and you don't want to, for every single user, can access the entire data that's stored in the instructor. Remember that in the instructor relation, we have what? We have an ID, name, department name, and we do have a salary. Okay? So if you don't want every single user to access this data, maybe you can create a view for this data. Yeah. So maybe create a view that contains the ID name, the department name from the instructor. It can be stored in one place. Or view, it depends, by the way. Either it's going to be Materializer View or it's going to be normal view. Okay. So again, a view can be defined as what? As a query that provides another way to present data in the database table in general. Okay, you can define this view based on, let's say, one or more tables. And the reason behind that, because we don't want it from all the user to see the entire logical data that we have. Okay, so it looks like you can define what's called virtual table or virtual relations, and specify or call this virtual relation a view, and we can assign user access to this view instead to access the entire table or entire relation. So we can summarize the reason why we need to have a view. First, it's like performance and convenience. Okay, so instead to have the entire access data for every time you're going to perform your query, maybe you're going to do what? You're going to let's say, create a view and allow the user to access or perform the query against this view. Yeah. One kind or type of view, we call this one Materializer View. So it looks like you have a relation or table, and this table is going to be stored on the disk, which contains this number of columns. Again, assume that we have relation student, and this relation student, for example, have student ID, name, GPA, for example, department, and social security number, etc. Something like this, okay? So maybe you can create a view that contains only portion of the data. Maybe it's going to be ID, name, and GPA in the department. And I put this one in one place. So every time you're going to perform a query that asks only the ID or any of these attributes, so instead you have access to the entire relation, that means you're going to pollute the buffer pool. I'm not going to talk about this one in more details here, but think or keep in your mind, every time you need to fetch the data from the disk to the main memory node that you're going to be processing, you're going to fetch as a block. So you see that if you access the entire relation that contains I'm going to try to come up with the example to exaggerate that, okay? You see that I'm going to have maybe 10 tuple or 10 attributes. And only you need to access, for example, only 2 or 3 attributes among them. So you're going to fetch a lot of data, and you're going to consume maybe, or you need only 20% from the fetch data that you fetch them from the main memory, from the disk to the main memory. Okay? So one thing you can define a view for the widely used derived relation, which combine, for example, every time you're going to perform, let's say, X two more relation together, every time you perform your query. And remember, when you try to access or perform join or Cartesian product, etc., this is expensive operation. Maybe you're going to create a view, calculate the more frequently access relation, okay? Then put it somewhere, as let's say, stored in one relation. Every time to perform your query to access this relation, instead you're going to execute your query, you're going to access the relation directly. Okay? So again, just to go over this one again, a view, or in some cases, is not desirable for the users to see the entire logic model, so we need to come up with what? We're going to say only specify, for example, a portion of the data on the high level, and you create like virtual relation, okay, which allow users in order to hide certain data from the views from the certain user. Okay, and why views? We can perform this one because for the performance and convenience, the most important thing. First of all, you can define, let's say, a widely used derived relation. For example, I'm keeping X relation R and S and retrieving, for example, attribute A, B, C more frequent. So instead you perform this one every time X relation R and S and retrieve the tuple that we're looking for, the attribute actually looking for, I can define this one as a view. So access one time. It depends on what type of view. There's one of them called Materializer View, which allow you in order to create a relation, for example, relation X which contains the attribute ABC, and you're gonna extract this attribute from the relation RS. So every time you perform your query, evaluate your query, instead you ask the relation RS, perform conditional product, join, then after that project the attribute ABC. Just go to the relation X and you say, I need to select attribute ABC. So it's gonna be much faster. Okay. Of course, we need to have concern about the space and etc. Okay. You can write simple queries against the view here. You see, instead said select ABC from R join S or whatever. You can say just select a star from X. It's much simpler query. Okay. As you mentioned, some databases going to provide Materializer View. So by the way, what I talk about this one in the top so far is called this like virtual view, or let's say a view, okay, in general, or virtual table. And this time, I'm not gonna extort the actual relation here. I just store to say the SQL query that you use in order to define this view. Okay, so in this case, I'm gonna select ABC from R natural join S. I call this one, or put this one under a view, okay? So generally speaking, view is a named query that provides another way to present data in the database table in general, okay? A view, again, or in other words, is a database object that defined as a stored query. So you have a query, store this query, then after that, every time you're gonna call and give this query, say stored query, a name. Every time try to use this view, actually you're gonna use this one as a virtual table or as a relation. But the way that the system is gonna execute it every time we're gonna come up with the fresh data, or execute this one every time try to access the view. Okay? In order to keep, in this case, the view is gonna be updated. There is another thing, type of view, we call this one materialize. What does that mean, materialize? Materialize, this means I'm going to create the view or create a relation in this view. So in this case, I'm going to go to the SQL query that you use in order to define this view. I'm going to execute it. Then I'm going to store this one on the disk. Now it's done. The data of the view is going to treat it as what? As a relation. Okay? If you modify the main relation or the base relation, for example, your SQL query that you define a view, acts the relation RS. After you create Materializer View, so create a relation, I will call this view X, and store the ABC, for example, extract from R and S. Now ABC is going to be filled with the data. Now after that, you modify R and S. So the problem here, the view is going to be outdated. So we need to figure out a way to make sure that the view is going to be updated. So we have two different types of view. The one is going to be treated as a virtual table. So in this case, it's going to be SQL query. It's going to be stored, okay, somewhere, and it's gonna given the name as a view. You use this one as a relation, but every time you try to access a view, the Postgres, or the database management system, is going to execute the SQL query in order to produce the content of this view, so you can use it. So always going to be updated. For the Materializer View, this is different here. You're gonna create, of course, you're gonna use SQL query in order to create a view, but you call this one a view materialized. That means that this view is gonna be executed at the time during the creation, and it's gonna fill with data. Then done. There is no relation between the view and the materialized view and the base relation or the parent relation, whatever the relation used in order to create this view. If you modify this relation R and S, now there is no connection. So you need to figure out or find out a way. Keep your mind, if you use materialize, in this case, yes, it's faster, but you need to make sure the data is going to be updated. Using virtual table on the normal view, most of the database in this case require from you to do what? You have, every time you're going to access this view, you have to freshly execute the SQL that you use in order to generate or create this view. The other reason in order to use a view is security. Make it more secure that you have like what? In order to secure your data. For example, you can add more access constraint based on this view. For example, they give you like a view, access, for example, portion of information about the student, and they can have restrict access control of this view. Not anyone can access this view. Or when you give this, multiple user access this view, they can only select, they cannot modify the data and etc. Okay, and also you can use it in order to hide some information from other users. And the example that I showed you before, using social security number, for example, or the salary on the instructor relation. Okay, so let's see how can you define the view. So just for simplicity right now, we're going to show you the easy way. Create a view as a virtual table, okay, which in this case is going to represent data of the underlying tables, okay. the symbol view can be also updatable. I'm gonna see how can do this one. Then after that, I'm gonna show you with example how can I do Materializer View. Okay. Right now the virtual view. So you create view v as, and here you're gonna use the SQL query used in order to create this view. In other words, so in this case, a view is gonna be what? It's like you are going to have a SQL query, and this SQL query is gonna give a name to this SQL query as a view, and you can use this one as a virtual table. Okay, so this is the simple thing. It looks like the same thing that we did with class. Remember that what here is different. Here I'm gonna create this one, and I can use in any place in the system. In the with class, I'm gonna use only within the query, the same query. Here you can use outside the query. There's another different, not exact thing, but this is one main difference between them, both of them. So I'm gonna create a view. And the name view, for example, faculty here, is going to contain information about the faculty here. I'm going to eliminate the salary. So now we have a SQL query. This SQL query create, let's say, a relation that contains the ID name and department name from the instructor. And I put this one in the view is called faculty. Now I'm going to use the faculty as a normal relation, okay, as a virtual table. So now if I ask you to find all the instructor in the biology department, the simple thing you're gonna do here, you can access the instructor relation, okay? Select, for example, the name from the instructor where they say the department name is equal biology. It's fine. Or maybe we can use a view. If this user, they try to answer this query, doesn't have access to the relation itself, instructor, only has access to this view, something like this, for example. Or it's not, I'll try to give an example how to use a view here. So we're going to do what? Select a star from the faculty where the department equal biology. When you execute your query, the SQL or the Postgres database management system do the following. You're going to say, okay, what's faculty here? Oh, it's the view. So in this case, this one is going to be substituted with the query that you use in order to create this view. So here it looks like we have a subquery select the ID name and the department name from instructor. You are going to execute, when you run this query, that's what's going to happen. Expand the view from the name and substitute using the SQL query using to create this view. Then you have to execute this one right now. Give me fresh data. Then you can use this like subquery, execute it, produce result set. Then after that, it's going to be handed to the outer query. Then now we give you the result. Clear? Kind of. Okay, that's the view. We can create a view of the department of salary total, for example. Again, it looks like similar with the width, okay, but different here. Width is going to be used only with the one query or the same query, here with anywhere. Okay, so it's going to be like virtual table stored there. Actually, it doesn't contain data. It only contains a SQL query that you use in order to generate this view. Create a view, for example, department total name, salary, for example, that contains two attributes, department name and total salary, and this is the SQL query used in order to create this view. So inside the system, we're going to create something, a new relation called department total salary, and inside this one, it's going to give me the SQL query like this. It's going to be stored here. So it looks like create SQL query, give the SQL query a name in order to use in order to as a view. Okay. Can you use the view define another view? Yes, it's fine. Okay, so this is just an example. Create a view called Physics for 2017, which lists all the courses section offered by the Physics department in the fall 2017. Okay, with the building and the room number of each section. So in this case, you have to access the course and the section here. Actually, we can do something different. We can use natural join here. If you use the natural join, so there's no need to have this one, right? I can use natural join here. Okay. Where the course department equal physics and the section semester equal 4 and etc. And actually there is no need to use the section course here. Because why? Because we have department name only belongs to the one relation, semester only belongs to one relation, in this case it's going to be section, and the year is going to be belongs to one relation, so we can simplify this one. In the short demo, I'm going to show you that this is the version How can you do this one in like a shortcut or short way or short version or other version of this query? Anyway, we create a view, and this SQL generates, for example, all the courses section with the building and room number for each section for the course offered by the computer science, or they say physics department. I can use this one in order to figure out all the courses, okay, that offered by the physics department, and also it's located in the Watson building. Okay, the location where the course is going to be taking place is going to be a specific building. So anyway, the goal from here, I know maybe someone is going to say you have easy way to do that, but one thing I'm going to give you like an example, just to give you like, we create a view, then we can use a view in order to create another view. Yeah, the same thing just with the class. We have a web, we create one class, let's say virtual table relation. Then after that, we use this one in order to create the next one. It's fine. But the problem here with the ones you're gonna using the same query, here we can use it in any place or everywhere. Let's say it's gonna be available there. I'm gonna show you how it's gonna be performed. This is how the view is gonna be executed. When we have, for example, in this case, when you can try to execute this one, the system is gonna say what? It's gonna be select the course ID or number from where? For the physics fall 2017. This one is going to be substituted with what? The actual query used in order to create this one. And here, when you use, for example, select the star from the physics fall 2017, this one is going to be expanded with the whole query that you use in order to create this view. Okay? Materialized view here is got a different story here. Just in this case, I'm going to create a view, and this view is going to have a physical copy of this relation. So it looks like another relation, and you can decide whether this one is going to be filled with data or not. The standard said you can't create this one, and you need to figure out a way how could you maintain. I'm going to show you how to do this one using the Postgres. Actually, write this one here. In the Postgres, you're gonna, when you create a view here, you're going to specify here, create Materializer View. So I'm going to add one extra command or an option here in order to, in order to specify this view is going to be materialized, okay? How can we update the view in general? You can update the view, okay? But when you update the view, you have some issues here. You need to think about it here. The first one, when you try to access viewing, okay? When you insert something to the view, you can do this one. But not in all the cases gonna work, okay? So there's some restriction. Let's have an example. Assume you have a faculty view that contains faculty ID, name, and the department. The faculty name and the department, right, yeah? We exclude the salary from this view. Now you assume that you're gonna insert into the faculty view. Can I do this one? Yes, you can do this one. But take a look here. You have the ID and the name, and you say the department, right? Yeah, the structure ID, structure name, and the department, then we exclude the salary. Great. This insertion has an issue here. The problem with this one here, when you try to insert something, the system is going to check the following here. First of all, when you insert to the view, this is going to be translated to the insertion command to the parent view, or the parent relation used in order to create this view. So when you try to insert inside the faculty, actually you are not going to insert here. You're going to insert in the original relation, which they use in order to create this view. Remember, when you create into faculty, this is only just a name that you're going to store or represent, let's say, or pointer to the SQL query used in order to create this view. It's not materialized, it's a different story. So here's just a name to the SQL query. So in order to perform any insertion, deletion, modification, can be translated to the command and can perform translation or execution or modification to what? To the actual data used in order or relation used to create this view. So here, you need to have two different ways in order to deal with this one. First, it looks like let's say insert. Let's write the command first into, let's say, instructor and the values 1, 2, 3. Now we need to have a parameter here. How about the salary here? We need to have a value. So it looks like translate to the insertion to the instructor. Instructor required from us to specify the value of the salary, right? So what's the value going to be here? No, it depends. Yeah. So we have two different ways in order to deal with the insertion. First, the easy one, I'm going to ignore this one, reject it. Okay, that's the first one you're going to perform here. You're going to be, so two ways in order to dealing with this insertion. Reject the insertion and return an error message to the user. Or you are going to insert tuple that contains this, say, instructor ID 3765 and the name is green and the departed music, and the salary is going to be null. It depends if the null value is allowed to be a valid entry for the salary. So see that this situation you need to think about it here. The other thing here, we can do some updates in general, but we cannot translate it uniquely. This is another problem. Sometimes you can translate the query uniquely, so you can perform insertion. And for example, as the case of the salary, if the salary can be has a null value, it's fine in this case. Or in this case, you try to modify something, okay? And the problem in this case maybe gonna cause an issue. You cannot uniquely come up with a unique way in order to interpret this query. Remember, any modification to the view, this one can be translated to the modification to the, let's say, the original relation, the parent relation, the base relation, used in order to create this view. Assume that we're gonna, in this case, try to create instructor information. We're gonna list information about the ID and the name and the building of what? Of each instructor in the university, okay? And this is information that we have. Good. And we said where the instructor department name is equal department name. So extract this information from two relations. Oh my gosh, no problem. So if you have insertion of this view, I need to translate this one to two different insertion. One is gonna go to the instructor and the second one go to the department relation. Okay? So assume that we try to insert that. We have the ID of the instructor, the name of the instructor, and here the building. Okay? Suppose that there's no instructor with this ID. We try to insert this one. This one is going to be translated to two different commands. Yeah, one is going to be insert to the instructor, and the other one is going to be insertion to a tuple to the department. Assume that there is no instructor with this one. Okay, and at the same time there is no department in this building. We don't have this data in the original data. Okay. So in this case, this is the command, the two translations. So I'm going to translate this one to the following. Insert this one into the instructor and also insert this one into the department. What's happening? We don't have an instructor, this ID, so I insert a new one. The name is given. How about the department? It's not given here. How about they say the salary is not given? For the, this is for the instructor. And this one for the department. I don't have the department ID. I do have the department to say, building, for example, okay, and I don't have the, what's this here, the budget. I don't have the budget. Okay, of course, the first one here we have a problem. Since the department is a primary key, we cannot have a null value, so this one can be rejected here. Okay, if we didn't specify this one, now we're gonna have a problem. Even if you manage somehow to insert this one to the instructor and to the department, okay, the effect is not going to be reflected here. So if you insert something to this view, when you select all the tuple from this view, whatever you insert is not going to be part of the result. Why? Remember, we said there is no department in the title building, so when you try to retrieve all the information from this view, you need to make sure that department name must be the instructor of the department name must be equal to the department name, and we need to perform this operation. So in this case, since we don't have department inserted, or it's going to be in this building, so in this case it's going to be null. So this tuple is going to be excluded from the result. So whatever you inserted is not going to be affected. It's going to be displayed in the final result. So in this case, it's a problem. Okay. So to summarize that, there is no way to update the relations instructor and department by using null values, okay, to get the desired update on the instructor info, okay? So generally speaking, because we have a problem like this, okay, modifications are generally not permitted, okay, on the view relations. This is the SQL, let's say, the standard said that, okay? Different database systems are going to specify different conditions, okay, under which they permit, the updates on the view relations, okay. So it depends whatever database system that you work with. So you need just to double check the manual of the database system for more details to see what kind of a view you can, what kind of condition. So just speaking, to be in safe side, we can, or the SQL standard come up with say a few conditions, based on this condition. If you satisfy them, then in most of the cases you're going to be managed in order to update a view. Okay. So like limited case would allow you in order to allow perform the let's say update a view. The from class has only one database relation. We didn't have more than one relation in order to build this view. Select something from only one relation, not two or more. Select a class must contain only attributes named in the relation. So this means there is no aggregate function, there is no distinct specification, there is no expression. You cannot say the salary divided by something. No, it must be student ID, name, and etc. Only the attribute less in the relation. Make it simpler. So in these cases, hopefully, yeah, it's allowed to update the view relation. But you're gonna see it's not gonna work in many cases. So right now, if you talk with anyone who wants the database, most of them are gonna say, okay, view you cannot update it. But there's actually you can do in some cases if you make it simpler. Okay. So anyway, there's no goodbye and no having. Even with this instruction, we still have an issue. Okay. Assume that to give you something like this. Create a view, history instructor that contains information about the instructor and the history department. Select a star. In this case, you're going to do what? Select all the instructor that belongs to the specific department. So the history department, all the instructor, put in this view. It's easy. One relation, simple. All the attribute that belongs to this relation, it's fine. But remember, if someone will say, I want to insert this tuple into this view. And here I'm going to say biology. Department is biology. So if you insert this one, okay, this one going to be translated to the insertion to the instructor relation, right? You're going to check if the instructor relation still have, for example, if the instructor relation doesn't have, let's say, instructor ID in this case, it's going to be fine. You're allowed to do that, okay? Otherwise, because the primary key constraint, the system is going to say, no, you cannot do that. The name of the instructor, the department, and this is here the salary which is going to be inserted here, okay? So we managed to insert this one to the instructor. But at the same time, if you try to retrieve the information for this view, do you think this tuple is going to be part of the result or not? It's not going to be. Why? Because here you said here where the department name is the history. So you insert something or tuple to the view, and this one is not going to be part of the desirable result or desired result. Yeah. So in this case, we do have an issue. Yes, someone gonna say, I think I can fix this one using what? I can use with the check option. Yeah, in order to make sure that this one is not gonna happen. So I'm not gonna allow you to insert this one unless this one satisfies the condition that the department name is equal history. If it's equal biology, since I'm gonna manage to insert this one to the lower level, to the base relation, but it's not gonna be part of the result, so I'm gonna exclude this one. Okay, so use it with the check, with the one thing that we can use with the view. So I think let me have a quick go over the view here. So the nice thing when you work with the Postgres, the PG admin, you're going to have a graphical user interface, so you have a full control. Let me go over one at a time. We're going to create a view. I don't know why I need to start in the beginning. Okay. You see that I'm going to divide this one into parts. Now we're going to talk about the views. For example, I wanted to create a view, okay, of the instructor without the salary. When you create this one, you run this code here. Okay. Take a look to the view here. You see the view here? If you refresh this one, and you see that the view is going to have like a view is called faculty with the columns here. Okay. That Postgres, how can it do this? It's going to store the whatever command that we have in the virtual table, and it's going to be stored here. It looks like what we create a SQL query, we give the SQL query name called faculty. Okay. Now, if we try to access this view, for example, I need to select, okay, the name. By the way, now you have a faculty here, yeah? Now you can specify the access right to the faculty. You can specify, for example, user 1, user 2, you have access to the faculty. User 3, you don't have access to the faculty, and so. Good. So we eliminate the salary. Now we can use this one in order to perform our query. I need to select all the, find all the structure in the specific department. I'm going to use this view. When you use this view, the system here, I'm going to do what? I'm gonna substitute the faculty name with this command. So it looks like you did something like this when you executed that. That's what I actually did. You see that? You substitute the name of the view with this command. It's gonna be a subquery. Okay? So let me execute that to see what the result will be. And that's the result that we have. Good. To change the definition of the view, for example, what if you can use what? Remember, we talked about this before. You can modify the name of the relation. You can change the schema of the relation, right? Here, for the view, I can define or change the view name or alter the view statement in general, okay? Or change the definition of the view. Here I've said, alter view, that means I need to modify the view, okay, faculty, and rename it to specific. You can specify add one query, remove, modify the change, or maybe you're gonna say rename to the new faculty. If you perform this one, so the system is gonna change the name of this use to the view from the faculty here to new faculty here, okay? You can define, if you wanna delete it, you can say drop view if exist. I use if exist. That's a good thing, because if the views exist, delete it. So if you run this one here, the view is going to, of course, you need to refresh. You see the view is not there. So if you try to use here, assume that I delete everything. We don't have a view. When you try to execute the system, you're going to say, I didn't know about this, anything about this relation. Okay? So we can use alter view in order to change the definition of the view or rename it to the new faculty. We can, for example, use drop view in order to delete or erase or remove the view. Okay. I'm going to create a view that contains the department salary. That's what we did here. You see that it's similar to the weather class. The nice thing here, when you run this one, now it's going to be available here. Okay. If you look out, get back the next day, the data is going to be there. So you can use this one or access the view here. Okay. This is how can you do this one with the physics for 2017. We have different ways to perform that. This one may be more easier, simpler with the one that we have in the slide. In the slide, we use the Cartesian product. Here, there is no need to use the Cartesian product. You just select cross natural drawing from section. Make sure the department of physics and the semester for 2007, because we didn't have 17 here. I need to rename this one to the 7 here and check this one what's gonna happen. And there's a view here. If you refresh this one, now we do have a view called physics 2007. I can use this one in order to access the data, in order to modify the data, and etc. Okay? I want to spend a few minutes to go over the Materializer View. Materializer View, that's different than the normal or virtual view. When you create Materializer View, so by the way, for this view here, if you use them, if you said you create this one time, okay? If you try to say, let me give you a command here. Select a star from, let's say, I'm lazy guy. Yeah. I think this is the name here that you have version 1. Yep. From this. Okay? When you run this, let's see what the result. My keyboard let me down today. This gives me the result, okay? So now after you create this view, if you modify the section or course relations, okay, and you execute this command, you see that it's going to be reflect the change. So you're going to get most updated. So in other words, when you create a view in this case, it doesn't mean that you're going to create a view and fill it with data. No, you're going to keep the definition. Every time you create this one only one time, every time try to access this view, the system automatically going to run the SQL query in order to fill this one with data. Always the data is going to be updated automatically. So during the runtime, execute the query. Now we get to execute this view in order to give you the result that I'm looking for. Materializer View is different. Now you create what? You create a relation, okay? Fixed relation, and going to be stored where? Not in the view. You're going to see this one is going to be stored in the Materializer View, different place in the Postgres. Different database management systems do different stuff, but most of them do something similar to this. Okay? So we have create Materializer View, and here we can specify the difference here, materialize, and here we can specify what? Specify whether we're going to fill this one with data or not. I'm going to say I'm going to create a view blank, contains nothing. Okay? There is nothing there with no data. When you run this one, you see the create Materializer View, and you go to the Materializer View, you see that we have one view here with a faculty M, which contains what? The ID, name, and department name from the instructor. Okay? With no data, there is no option. It didn't fill. It's not populate with the data. Someone gonna say, can I use it now? When you run this one, you try to use this view, the materialized one. By the way, use a view as the normal relation. You can combine, you can use a natural join with other relation, whatever you are gonna do with it. When you run this one, the system gonna say, okay, I know you create Materializer View, but this Materialized View hasn't populated with data, any data yet, nothing there. You didn't fill this one with the data, that means you cannot use it. In order, that's why we said Materialized View has a different way. How can we handle this view? You need to make sure that we're going to fill this one with the data, and then after that you need to make sure that this data must be updated. Now I created Materializer View, then I'm going to say I'm going to fill it with data. In order to fill with data, you're going to, by the way, different database management systems do different stuff. This is not the standard. This is only for the Postgres. They're going to say to load the data, refresh Materializer View with the name. Now, when you perform that, do you know what's going to happen here? Now, the system going to do what? It's going to execute the definition that we have that's using the Materializer View only one time. Then after that, fetch the data from the instructor, the current data, whatever you have right now in the instructor, filter out, you say, project the ID, name, the department, and store it in this relation. Now fill with data, okay? Now, if you said select star, or whatever data from this Materializer View, the system can say, yes, I do have this one. Now, here at this point, if you modify anything in the instructor relation, the change is not going to be reflected in the view. Okay? Materialize the view, I mean. Why? Because it's going to be executed here. At this moment here, I'm going to load it with the data. Then after that, there is the connection between the Materializer View and the base relation used to create the view is going to be disconnected. There is no relation anymore. So if you update, modify, whatever tuples in the original relation, and I cannot see the effect in the, let's say, the Materializer relation. Okay? Unless I specify something. If you want to update, you can update this one using what? You can say, give me a second. Oh, I remove this one. Yeah, refresh the Materialize this one. You can use this one to refresh. Okay? So if you can refresh this one, this means right now we're going to go ask to the, let's say, to the faculty, or let's say, to the original relation or base relation used in order to build or create this view and get the update this one or make like fresh copy or populate with the fresh data. Okay? So it looks like the Materialized View is static. If you modify the, unless you're going to specify or refresh this one with the data. For the normal view, virtual view that we did is not materialized. I'm not going to store anything. I'm going to take the SQL query, store it under a specific name. Then I'm going to use this one in order just every time you access the query or access the view, I'm going to load fresh data, execute it. Okay? This one maybe is good for the performance. You do this one time because I do have maybe many queries that actually do the same query here. Ask always the instructor or more than the relations. More frequently ask 5-6 relations, then it's a good idea to put this one in Materializer View, store the data in one place. So every time you try to access the same piece of information, there is no need to recompute the data. Just read the data from the Materializer View. And keep in your mind, you need to update or refresh this one. If you want to delete it, yes, I can use this one. You can say here, Materializer View. Then if you check this one here, refresh, it's gone. Okay? We talk about how can you update the view definition, etc. For example, how can you perform insertion, etc. Assume that I said create or replace history instructors. We're going to create just a view that contains a list of the instructors for the history department. And here I add the with check option. So in this case, if you did that, something like this, if you run this, and here you're gonna have like a view, just refresh, you see that we have a history instructor. Okay? So when you have this view, now we've tried to insert something. Remember I said, in order to have a view, make it updatable, make sure that view is gonna be contains, symbol, attribute. There is no, let's say, expression. There is no, let's say, aggregate function, and etc. And also acts only one relation, no more. Okay, something simple like this. If you try to insert this one, history instructor, and since we said use the with check option, if you try to insert something here, the system is gonna say, wait a second, you cannot do this one, or you can do this one. It depends. Okay. Here, if you try to insert something biology department, remember we need to make sure if we modify the view, we need the change or the effect gonna affect this view. Okay, it does mean that in this case you modify this view, so this one is going to be translated to the let's say the query to the lower level or the base relation. Now you modify the base relation, but the desired effect is not going to be shown here in the view. So that means what are you doing here? Okay. So here, in order to prevent that, to make it, this view is going to be updatable, so the effect is going to be even, or also going to be appears in this view. If you run this one, the system is going to say, wait a second, you try to insert the department is the biology, and here you have a condition, you said. You are not allowed to modify this view, or any modification in this view must satisfy this condition. History, the department name is equal history, otherwise I'm going to reject this one. That's why I said with the check option, with one constraint, we can edit here in order to make sure that any modification of this view, okay, must satisfy this condition. Must have the department name equal history. Otherwise, you are not allowed. If you manage to do this one, yes, my view is going to be great in this case. Okay, back to the slide. Let's take a look to the transaction, which is one interesting subject. Then after that, to see what we can do. I think we still have time. We can cover more. Yeah. And this is just an example. You try to, that example, remember that we said if you try to update the view, but we cannot translate the query, or the update command uniquely because this view contains more than one relations. So if you try to update this one, for example, try to insert mutable for this view that contains ID, name, and building from the instructor department. Okay, with this data, this is going to be translated to different query. Okay, if you do this one, then the result is going to happen something like this. You see that now we have the relation with the instructor contains something like this, and the relation with the instructor, the department contains something like this. Although this one is not going to happen because if you have the department name, it's going to be primary key, so it's going to be rejected here. Okay, but assume you manage to do this one. Now, if you try to do what here? You try to select, okay, all the ID, the name, and the building name of each instructor in the university here. So this one, whatever you add here, this one is not going to be part of the result. Why? Because I don't have the department name here. It's not going to equal any department name here. Someone is going to say, but this is null and null. Remember, null is not equal null. Okay? You cannot compare this one. It's going to be false in this case. Unless you're going to use is null. Yes, is null, yes, it can be true or false. Otherwise, you cannot compare the null values. So whatever you're going to insert is not going to be part of the result. So the desired effect is going to be affect the view, so it's not going to happen. Okay,